Hello, y'all. I might notice that I am not in my usual location. This is because I encountered some technical difficulties and I am currently re-recording my session, although I am doing this by myself. So there will not be any questions, or I guess I'll make up some questions if should the need occurred, but I'm doing this on my own. I'm gonna try and go ahead and maybe speed through the entire worksheet just because I took so long to get this video out. I apologize for that. If this is an inconvenience to you, I'm doing my best. I will do better as the year progresses. I've just been having some technical difficulties. But with that being said, I'm going to go ahead and speed through this and hopefully get this out before the day ends. The first two questions are about math, specifically derivatives. The first question asks, what is a derivative? All a derivative is the instantaneous rate of change. So I'm just going to draw y equals x squared. Say, what is this, 1, 1? I hope this comes out well. At this point, it has a slope of 1. However, as you go along on this function, this slope progressively changes. This is the function y equals x squared. The derivative of y equals x squared is 2x. We can use this derivative in order to calculate for the slope at any point along this function. This is the basic concept of derivatives, and it pops up a fair amount throughout the year. And the next question basically kind of just goes over rules of taking derivatives. So the next one is take the derivative of this function. I should probably bring this up with me. Squared minus 1/2 x plus e to the 1/2 x minus 5. Can you see that? I think you can. I'm pretty sure. Okay. So we're going to take this one at a time. F prime of x, or the derivative of x, which is written both of these ways. They're interchangeable. I usually use this just because I'm lazy. I want to take this one at a time. X squared. This is the power rule. So, okay. Power rule. X to the n minus 1 times n. We have x squared. 2 is n. We're going to bring 2 in front and subtract 1. So it ends up becoming 2x to the first, or 2x. Here with me. Next one is 1/2 x. Same concept, except now we have a constant in front. 1/2 x to the first. Even though it's 1, we're going to still move it in front. Minus 1/2 times 1, which is what we do with constants. If they're being multiplied together, you just leave the constant alone and just multiply by whatever comes down. X to the 1 minus 1, or 0. Anything to the 0 power is 1, so you're left with negative 1/2. E to the 1/2 x. The derivative of e to the x is e to the x. The integral of e to the x is e to the x. Plus c, but e to the x. It doesn't change. However, this isn't just e to the x. It's e to the 1/2 x. So I'm going to call 1/2 x u. The derivative of e to the u is e to the u times the derivative of u with respect to x, in our case. So u is 1/2 x. Wait, yeah, 1/2 x. The derivative of 1/2 x is 1/2. So the derivative of e to the 1/2 x is just 1/2 times e to the 1/2 x. The next part is just minus 5. I'm going to give you a long way of thinking about it. You have negative 5. You can imagine there is a 1 being multiplied by negative 5. Doesn't change the value. You can also think of it being multiplied by x to the 0. It's still 1. It still doesn't change it. You can still use the power rule. Multiply it by 0, and then to the 0 minus 1, or negative 1. The negative x to the negative 1 is not going to matter because the entire thing is multiplied by 0. So the entire thing is just 0. However, in your calculus class, they're just going to tell you that the derivative of a constant is just 0. You can also think of it graphically. Whenever you graph a constant, it's just a horizontal line. The slope of that line is 0. So that is the answer to that derivative of this function. 2x minus 1/2, plus 1/2 e to the 1/2 x plus 0. Or you can leave the 0 out. Whatever you so please. Also, tell me if y'all prefer this whiteboard thing versus this, I forgot what it's called, dot can. I'm personally just doing this because it's like, what, almost 10? I'm kind of getting sleepy, and I still have homework to do, so I'm just trying to stay awake. But tell me if y'all prefer this over me doing the dot can, because if y'all prefer this, I kind of prefer this. So if y'all prefer this, I would be more than happy to do this rather than what I've been usually doing. A man named Merrick runs as fast as he can along a moving sidewalk in an airport from one end to the other, taking 2.5 seconds. Then a zombie appears, and the man runs as fast as he can back along the sidewalk to his starting position, taking 10 seconds. What is the ratio of the man's running speed to the sidewalk speed? That was a lot of words. Y'all can't see it. Hopefully you're going along. You have the worksheet right in front of you as you're watching this. So I'm going to be drawing a picture because I don't like words. I like pictures. We have this man on this moving sidewalk. Make it look kind of like a little conveyor belt, little looking thing. And goes at a velocity, I'm going to call it Vm. And this little conveyor belt is helping it. I'm going to call it Vs. Then a zombie appears. Oh wait, let me draw him on the other side. Oh, don't want that to fall. Oh, son of a nutcracker. Stay on. Okay. Setup. Same man running the opposite direction for his life. This zombie, give him little X eyes. I mean, like little drool or something. Going at the same velocity Vm. However, the conveyor belt is no longer helping him. It is making him go slower. So the velocity of Vs is still going in the positive x direction with respect to the conveyor belt, or I guess the third person observer. However, we're actually going to do this problem with respect to the man running. Me just saying that doesn't necessarily mean a lot to you, but it's going to make sense in a little bit. This time from here, when he travels an unknown distance, I'm going to call it d. The time it took him to go from left to right was 2.5 seconds, I think. Yep. And this, it took him 10 seconds. This is what is known as a relative motion problem. However, it is one-dimensional. It is strictly in the x-axis. He is not moving up and down. He is not moving diagonally. He is just moving along an x-axis. In, I think, Friday's lecture, Dr. Marble went over something known as the Galilean transformation and the Lorentz transformation. As far as I know, whenever I took this class, we never went into the Lorentz transformation. Unless you're a physics major, I don't know that any engineer, computer science major, or math major goes into Lorentz transformations. That's something that I'm barely going over this year in my physics class. So I don't know that y'all need this, but we're not even, but I'm just going to go over the Galilean transformation. Y'all shouldn't have to be tested, or y'all shouldn't get tested on the Lorentz transformation. Study it if y'all have homework on it, but I'm not going to go over it because I really doubt this is something y'all are going to get tested on. So we're going to stick with the Galilean transformation. Now can I remember it? V equals V prime plus big V. Your book, I don't know what your book, I think your book writes it in like subscripts. Let me put my vectors. I don't really remember what the subscripts are. You can see it like that, you can see it like this, or you could see it like U equals U prime plus V. I think for this problem, I don't even think I'm going to be using either of those forms. I'm going to be writing it in like some form of subscripts. My little eraser is over here. I would say memorize this, but understand what it means. It's kind of confusing at first, but with more practice, it'll make more sense. So like I said, we're going to do it with respect to this man running. But we're going to do this first scenario first. In the first scenario, this man, let me draw an axis. This man is running in the positive x direction. This conveyor belt is helping him in the positive x direction. So I'm going to say the velocity of him going forward is equivalent to his running velocity plus the conveyor belt velocity. Now, if you're in my session, I actually told y'all wrong. I was doing it with respect to the conveyor belt. However, for this question, you're not actually supposed to do that. In the second scenario, so this is scenario 1, this is scenario 2. Scenario 2, I'm going to say velocity backwards. like I said, we're doing this with respect to the man. I am walking in what I think is the positive x direction. To you, with this axis, I look like I'm going in the positive x direction. However, whenever the zombie appears, I am turning the fuck around and I am running the other way. My axis just changed. My forward just went this way. To y'all, I'm going in the negative x direction. To me, I'm going in the positive x direction. This man did the same thing. His axis just flipped, or his x-axis just flipped. So positive to him is y'all's negative. So to him, it is Vm minus Vs. So whenever I first did it, if you were there for the session, I told you wrong. I was doing it with respect to the conveyor, well, not necessarily conveyor belt, but with respect to a third person. I should have done it with respect to the man. Now, I have two equations. What do I do with these equations? Well, I have to relate them in some sort of way. I have to, because in the end, it wants me to find a ratio between the velocity of the man with respect to the conveyor belt, I think. Yeah, or sidewalk. It says sidewalk. So in the end, I want something that looks like this. How do I get there? Well, I know velocity is equivalent to displacement over time. I haven't been drawing. I'm pretty sure. Yeah, those are velocities, those aren't speeds. Yeah. Okay. Displacement over time. Well, the first one, Vf, is some displacement over time 1, which is equivalent to Vm plus Vs. The second one is some displacement, the same displacement, over a second time 2, Vm minus Vs. Some of y'all might have already figured it out. For some of y'all might have not. I can actually divide these two equations. I'm going to divide my first equation by my second equation. So I'm going to get d over time 1 divided by d over time 2, which is the same as saying d over time 1 times time 2 over d. The displacements are going to cancel, and we get time 2 over time 1, which is like 10 divided by 2.5. That should be 4. 4 seconds. Well, let me divide these equations. So you get 4 seconds as equivalent to Vm plus Vs over Vm minus Vs. Now, at this point, it's just a matter of moving things around. 4 Vm minus Vs, Vm plus Vs, distribute. Move Vm and Vs to the respective sides. Can you still see? Yeah, y'all should still be able to see. Yeah. Plus 4 Vs plus 4 Vs minus Vm minus Vm. You get 3Vm equals 5 Vs. Vm over Vs equals 5/3. You can move that into a fraction. Move that into a decimal. I just like keeping it as fractions personally. But yes, that is how you do that question. Yeah, I don't. Yeah, I think I'm going to go ahead and erase it. Next question. Jimmy is falling at a constant speed of 30 meters per second. At what angle from the vehicle does Jimmy appear to be falling as viewed by the driver of the car traveling on a straight, level road with a speed of 50 kilometers per hour? Okay, again, draw a picture. I'm a very visual person. Most people are pretty visual people. Does my boy? Yep, I do. I got this little cart. I got this skydiver. He is falling at a constant velocity of 30 meters per second. At what angle from the, oh my God, At what angle from the vertical does Jimmy appear to be falling as viewed by the driver of the car traveling on a straight line, straight level road with a speed of 50 kilometers per hour? I swear to God, I can read. Okay, so this person, I guess, is traveling. I want to say this is V car. This is V skydiver. This one is going 50 kilometers an hour. Now it's 30 meters per second. And I want to find the angle from the vertical. So that's this little place over here. Well, to me, this is just trig. Got a y, I got an x. Want to find theta. So I got my adjacent, I got my opposite. I don't have a hypotenuse, so this is tan. Tangent of theta is equivalent to 50 kilometers an hour over 30 meters per second. Inverse tan, so you get theta is equivalent to tangent inverse of 50 kilometers per hour over 30 meters per second. Do not just plug that into the calculator. There is a big problem with this. The car is going in kilometers per hour. This man is going in meters per second. You cannot just divide these two numbers. They have to have the same units. We typically do things in meters per second. So I'm going to change kilometers per hour to meters per second. 50 kilometers per hour. let's start with the kilometers. I want it to be in meters. So I want meters on the top. So I have 1 kilometer, because I want kilometers to cancel, times 1,000 meters, which are in 1 kilometer. I want to go from hours to seconds. Yeah, hours to seconds. So hours is currently in my denominator. So I want to get rid of it by putting it in the numerator. I think there are 360 seconds in an hour, right? 60 minutes times 60 seconds, 0, 0, 6, 6, 36. 3,600? Yeah, 3,600. Right, I can do math. 0, 0, yeah, 36. Yep, 36 seconds. Yeah, because I want seconds. Yeah, seconds in the denominator, hours, cancel the hours. Yep, so now at this point, you just multiply across. Doop, 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 doop. It's going to be something. 50 times 10 is like 500. 500 divided by 30. Where's my calculator? It's in my bag. I think it's like, I don't know, 500 divided by 30-ish. I don't know. I'm going to guess like 300, I guess. 50? No, 500 divided by 36. Oh, I wasn't even close. 13.88. Wait, that's not even the right one. Yeah, it is. Yep. Marker. So he is going 13, really? Huh. 13.88 repeating meters per second. Put that in for tangent, inverse. That divided by 30. Theta is equivalent to about 24.8 degrees from the vertical. Next question. An astronaut in a horizontal centrifuge has a radius of 6 meters. Blah, 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 blah. An astronaut is rotated in a horizontal centrifuge at a radius of 6 meters. What is the astronaut's speed of the centripetal acceleration if the centripetal acceleration has a magnitude of 7.5 g? Okay. I don't know why I smacked that down. I need it with me. So this astronaut guy is in a centrifuge. Where is that guy? It says radius, so I'm gonna assume it's a cylinder. I'm pretty sure most centrifuges are cylindrical. Radius equals 6 meters. What is the astronaut's speed if the centripetal acceleration has a magnitude of 7.5 g? Well, What is centripetal acceleration? The word centripetal means center seeking. So it is an acceleration pointed to the center of the circle. Yeah. Centrifuge. Centrifuge is the opposite of centripetal, so it's from the center outward. How does one solve this question? Well, I know centripetal acceleration from your book, it should say centripetal acceleration is v squared over r. Yeah, v squared over r. Well, there is no such thing as velocity in a circle or in circular motion. This is because the direction, whenever you're traveling in a circle, is always changing. You're never traveling in one direction. Every instant, you're traveling in a different direction. And since velocity requires a direction, circular motion has speed, not velocity. So we know that this thing is a speed. It's not a velocity. So let's just solve for speed. Move things around. V is equivalent to the square root of centripetal acceleration times radius. G is 9.8, so we have V is equivalent to the square root of 7.5 times 9.8 times 6. Plug that into a calculator. Square root of 7.5 times 9.8 times 6. 7.5, I'm just going to round that to 8. 9.8 is almost 10. 10 times 8 is 80. Times 6 is like 480. Square root of 480. I don't know. I'm tired right now. 21. Really? Oh, cool. I just realized, I think the one that I printed out might have different numbers. If the numbers that I'm spitting out are different than the ones that you have, it's the same process, just use your numbers. I think I don't know, I think the one that I'm talking about, it should be the one that y'all have, or the one that's most recently uploaded. If you downloaded it really early, there's a good chance that you might have a different copy, because I'm looking at my answer sheet and I think this is a different copy. So if you have a different copy, it should just be the same process, just different numbers. Okay. A slingshot, okay, this one actually kind of threw me for a loop a couple times. So let's work this one out. A slingshot located at sea level fires a ball with an initial speed of 82 meters per second. The initial angle is 45 degrees. The ball lands in the water after traveling a horizontal distance of 686 meters. How much greater would the horizontal distance have been if the cannon had been 20 meters higher? Now, I think it was this question that made me switch the numbers because I think this question came out with a funky answer. If you have the one that has different numbers in this, work it out. I don't 100% remember if it was funky or not, or how funky it was. A good chance that I just did it wrong, but I'm pretty sure the one before this had funky answers. I'm going to say that's my expected spot. Travel the distance of 686 meters. Yeah. Had an initial velocity of 82 per second at an angle of 45. Now, the second picture, 20 meters, 86. Make that the same length. But now, there's just some x that we don't know. We're solving for this arbitrary distance. Arbitrary may not have been the right word, but I'm tired. So, what does one do? Although it's kind of late for saying this, but like if you haven't been doing so, pause the video before I answer it, and then see if what you did matches what I did. It doesn't really help that I just solved these answers for you and you just copy them down. That doesn't really help. Actually, like, make a good attempt to, like, try and figure this out. Because, you don't get better at problem solving by just copying someone else solving problems. You get better by, trying to solve them yourself and then, like, messing up a bunch of times. So, with that being said, assuming you've paused the video, what should have, popped out, I guess, is that, this is a question about motion. This is a question that involves constant acceleration because acceleration is not changing in either one of these scenarios. So this is a motion with constant acceleration, which means this is a kinematics problem. What are our kinematic equations? Vf equals V naught plus AT. V naught equals, Vf squared equals V naught squared plus 2a delta x. Delta x is equivalent to V naught t plus 1/2 AT squared. I'm actually only going to use like one of these, but I've said this in the last session. I've said this in every tutoring session that I've ever had. Memorize these equations. They pop up throughout the year. They pop up now. They'll pop up next week. They will pop up at the end of the semester. These are important. Memorize them. I cannot stress that enough. Okay. Now, this next part, I've heard it called the toolbox method. So I guess I'll call it that. I've just called it like filling in a graph or a chart. Because mine kind of looks like a chart. V naught, Vf. Can you see this? Yeah, you can. Delta A T. What do I know? Initial velocity. I know initial velocity in the x and the y. The initial velocity in the x is V naught cosine theta. V naught in the y is V naught sine theta. I also know acceleration. Acceleration in the x is 0. That baby does not change its speed in the x direction from beginning to end. Y. Y is g. Now, this is where it kind of gets funky. Depending on where I start my question depends on the rest of these variables. So, I didn't draw this very well, but during this little trajectory, I guess, is the same thing as this. From here on is new. How do I explain this? I guess one of several ways. Only two ways popping up in my head right now. But one of two ways that I think of whenever I solve this. I'm going to put my axis right there. Do I have anything I can throw? I'll just throw this. Let me see. That wasn't very good. Oh, let me throw this. Okay. That thing traveled in an arc. So from whenever I started, traveled in an arc. Let's just say that's where it's that was the same x height. Not including like air resistance and stuff like that. We're in a vacuum, and I can somehow breathe in a vacuum. I can't think of anything else that would make it change. It had a same initial, its initial velocity is the same as its final velocity. From here down, we don't know. At its peak, it has zero velocity. Well, it has x, but it has zero y velocity. It's not going up, it's not going down. It's just there. And then from its peak on, it's accelerating downward at 9.8. I like to think of it like this. From start, it has a axis that looks like this. Up is positive. This is my left, so y'all's right. It's positive, x. But once it reaches this peak, I like to think of it as its y flipping from up being positive to down being positive. So from the peak on, y is positive. You don't have to think of it like that. That's just how I like to think of it because it helps with my negative signs. And I'm about to show why. Thinking of it like that, I can put a positive 20 here. If I thought of it as its y downward is still negative, this would be a negative 20. And this would be a negative g. Thinking of it the way that I like to think of it, I can just put two positive numbers. If you want to do it the other way, you can go ahead and put two negatives. Either way, you're going to get the same answer, I would hope, I would think. But I just like to do it this way, and I know this one's correct because I worked it out like this. You can go ahead and, if you want, you can do it in negatives and see if you get the same answer. But I know this one's correct. Next part, what do I do now? This is all I can solve. Well, I guess I can put x, but I don't know what x is. I'm trying to solve for this. However, in the x, I got three unknowns because I don't know what this final velocity is. I know its final velocity if the final was here, but final isn't here. This is my initial. Final is down here. I know acceleration. I don't know the time. And I only know the initial velocity. And my y, I know initial, I know the distance, I know the g, I just know time and initial velocity. I can solve for that. However, what do I want to solve? Do I want to solve for final velocity or do I want to solve for time? I want to solve for time. Here's why. Say I solve for final velocity. Okay, I solve for final velocity. I have some number. Okay, what does that help? What can I do with that? I can't solve for this final velocity. I can't solve for that x. I can't solve for that t. The only thing I could do is solve for time. Now, that's what I'm going to do in the first place. I solve for time. Well, I don't want final velocity. So that has final velocity in it. It has time in it, but I don't know final velocity. This doesn't even have time in it. So I don't even want that either. I want this equation. Sorry. So I'm going to solve for time. The only thing about this equation is I can't set this equation to t equals something. I'm going to have to use something very special. So I'm going to set this equal to 0. So 0 equals 1/2 at squared plus v naught t minus delta x. I put it in that order for a very special reason. If you can guess the reason, great. If you can't, that's okay. I'm about to tell you. This is a quadratic equation. There's something special for quadratic equations called the quadratic formula. I can solve for t using the quadratic formula. The quadratic formula, if you don't remember, negative b plus or minus square root of b squared minus 4ac over 2a. Memorize this. It pops up a lot. In physics, I imagine it probably pops up a lot in engineering, although I can't really speak for that. That's more of an assumption. But if you do physics, if you minor in physics, or you major in physics, memorize this. If you major in math, memorize this. But I'm assuming since most of y'all are probably like mathy, hard, like majors, it'd probably be a good idea to memorize this equation if you haven't done so already. So now I fill in the blank. Well, I guess just fill in the numbers here. 1/2 times a is g, so 1/2 times 9.8 is 4.9. T squared plus initial velocity, so v naught sine, let me put in numbers. 82 times the sine of 45. 45 is the square root of 2 over 2. 82 divided by 2 is 41. That's just 41 times the square root of 2. I don't want to put decimals, just I'm not a big decimal person. I like keeping things with no decimals. So I'm just going to put the square root of 41 times square root of 2. If you so choose, you can put in a decimal, that's fine, or you can just put it in like that. Whichever you prefer. I just like doing it like this. Times t minus delta x. So it's going to be minus 20. If you put in like two negatives, this would have been positive and this would have been negative. Whichever you prefer. I solved it like this. That's just my personal preference, but if you wanted to do it the other way, perfectly fine. Now we start putting in, or in this case, we're going to put t. Now you start solving for t. We start putting in things. Negative 41 times the square root of 2. I want to put plus, or I'll just put both. Plus or minus 41 times the square root of 2 squared minus 4 times 4.9 times negative 20. All divided by 2 times 4.9. Wait, yeah. I'm going to plug that in. T, I already solved for this, right? Wait, this is the bad example. I solved this earlier. I got like 0.33. I don't remember. I'm just going to put what 33. It's 0.33 something. I want to say it was 3.5-ish. Something like that. Whenever you put in minus, it's going to be like negative 12 something. La la la. Okay. I don't know about you, but I have never traveled backwards in time. That's just me. Maybe some of y'all have, but last time I checked, I've only gone forward in time. If I could go backwards in time, I would have done it. We've done a lot of embarrassing things. But as far as I know, time only goes forward, so we can only work with positive times. So this 12th, we don't need to worry about it. It's just this one. Now we have time. The great thing about time is that it goes in for both of them. So I don't need this little line here. Time for both of them is straight up 0.33, I think, 5. Now, I have two unknowns in the x. I don't need final velocity. Now I can just solve for delta x. What equation am I going to use? This one doesn't even have delta x in it, so nope. This one has delta x, but it has final velocity, so that's two unknowns. Nope. I don't use the same equation. Except this time, I don't need to use the quadratic formula. So great. Delta x is equivalent to It's going to be the same thing because cosine and sine of 45 are the same. So it's going to be 41 times square root of 2 times time, which is like 0.335, plus 1/2, 4.9, times t squared, which is 0.335 squared. That's going to end up being, I don't remember what it was. (41 times square root of 2 times 0.335 plus 4.9 times 0.335 squared. It's almost 20. See, that bothers me. But that's what I got. Delta x is like 19.97. It's about 20 meters. I don't know if I've been doing that. Don't forget units. You'll lose points and then you'll hit yourself afterwards. Don't forget your units. I might have been forgetting them all this time, but don't do what I just did if I had been doing that. Okay. Last one. I just realized I think there's a typo. Where did the other one go? Oh yeah, this is it, isn't it? Yep. Yep. There's a typo. It says a Zoraida. I was about to say just Zoraida, but oops. Zoraida drove in a circular path with a radial acceleration of 3 times 10 to the 14th meters per second squared. That's supposed to be squared. I'm sorry. What is the speed of the Oh my god, I really fucked up on this, didn't I? Oh, I'm sorry. Oops. What is the speed of the electron? What is the speed of Zoraida if the radius of its circular path is 15 centimeters? Well, you can tell I did not change these numbers. I really should have them. Because Zoraida is driving really fast. So I'm just going to do like a bird's eye view. Radius equals, oh wait, it doesn't, oh yeah, it does. It gives you 15 centimeters. She has radial acceleration. Why don't you just say centripetal? Yeah. Radial acceleration of 3 times 10 to the 14th. And what is the speed of the electron? What is the speed of Zoraida if the radius of its circular path is 15 centimeters? Well, what is it? Well, we kind of solved this problem earlier. I forgot what. I think it was like number 2. Yeah, I think it was like number 2. Number 3. Well, radial, I mean, it says radial acceleration. Radius, radial. Same thing as centripetal. Centripetal acceleration equals v squared over r. Memorize that. This is not going to be the only time that this pops up. I mean, also, like, understand it. Like, go into the book and read it and, like, understand why this is true. But also, memorize it. I have a radius. They gave me a centripetal acceleration. They want speed. This v is a speed because there's no such thing as velocity whenever you're moving in a circle. So v is equivalent to the square root of AC, or ACR. It would have been so cool, like if it was like ARC to say the square root of arc. So you're gonna get square root of 3 times 10 to the 14th times 15. That is wrong. It is not times 15. This, wait, let me just make sure. Yep. 3 times 10 to the 14, that is in meters per second. You cannot multiply meters per second with centimeters. That is wrong. They have to have the same. Centimeters, you can do one of two things. You can go ahead and like straight up like just convert it to meters, which is going to be 15 centimeters. 1 centimeter is equivalent to 100. No, that's not true. 1 meter is equivalent to 100 centimeters. It's going to be 0.15. 1.5 meters. And you can put it in like that. Or you can understand that the, what is it, unit? Yeah, the unit centi, or the, what is it? Prefix, centi, and centimeter is times 10 to the negative second. And you can just put 15 times 10 to the negative second. Whichever you prefer. Both are true. So this is times 10 to the negative 4. That's times 10 to the negative second. It's going to be like something times 10 to the 12th. And then it's going to be square root of that. So it's going to be like times 10 to the negative 6. Or times 10 to the 6, I think, ish. 15 times, no, not 15. Haha, funny. 3 times 10 to the 14th times 0.15. 1, 2, 3, 4, 5. Oh, wait, shit. Oh, sorry. I need to stop doing that. 1, 2, 3, 4, 5, 6. Oh, shoot. 6.71. 6.71 times 10 to the 6th. There's probably like a prefix for times 10 to the negative 6. I don't know it off the top of my head, but that's meters per second. You can probably convert it into like something else that's like whatever times 10 to the 6 is. I don't know what it is off the top of my head. But if you know it, you can put it in. B asks, what is the speed? Oh, wait, no. What is the period of the motion? What is period? Well, period is the time it takes for this Zoraida that is moving at the speed of an electron to complete one complete revolution. Why is she driving at the speed of an electron in a circle that's super tiny? I don't know. But she is. So, period. Symbol T. Period is always measured in radians. Whatever you put in there has to be radians. What's that going to be? I'm sorry, I had a brain fart. Okay. 2 pi times r on the top. What is it? Circumference of a circle. Yeah, 2 pi r. Circumference of a circle. Divided by my velocity. Or no, speed. What was it? 6.7. 7.1 times 10 to the 6th. This actually works out still. This is meters. This is meters per second. Yeah, meters are going to cancel. You have something that's unitless times seconds. I mean, divided by seconds. Wait. Yeah, multiplied. Yeah, because that's meters, it's going to flip. Yeah, you're going to end up with seconds. Plug that in the calculator and you get an answer. Over here, I have written down 1 times 1.41 times 10 to the negative 7. Let's see if that's true. If 1.4049 yada 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 times 10 to the negative 7. Yep. I don't know where I got the 1 from, but I probably like rounded. That's really fast. I don't know an abbreviation for that, but you can probably find one. That is the end of the worksheet. I don't know how long this took. I can't see a time on there, but there's the end of it. I hope this was very helpful to you. It's a little too late now, but please, I hope you stop the video and then just like follow me. That was sad. If any of this didn't make sense, I mean, you can go ahead and like message me on Remind or you can email me. I'm not gonna guarantee that I'll respond, like at least punctually, just because I'm also a student and I'm also busy. So, but I will respond as soon as I can. But I cannot guarantee that I'll respond punctually, given my situation right now. It is currently like almost 11, and I still need to do homework. I did want to address something. Somebody asked me last semester, whenever I was first time tutoring this class, they asked me, how do I get better at physics? How do I get better at like solving problems? Well, I'm going to go ahead and straight up tell y'all there is nothing that I can do, there's nothing that I can say that is going to like make it, whoa. Sorry. But yeah, this is something that strictly comes with practice. Unless you're like a genius and you can just like, whoa. But unless you're like that, it's just something that is going to take practice. It's just going to take constantly doing problems like this and messing up a lot and pulling out your hair and crying at night. There's not really a if you it's just a matter of figuring out what are your study habits, fixing your study habits. How do you study? What methods are better for you? Are you a night owl? Or are you early bird? Or are you both? Do you need a lot of sleep? Do you need not a lot of sleep? Sorry. I don't know, I've been burping a lot today. But yeah, it's just a matter of sitting down, opening that textbook, maybe not so much reading it. Read it, please read it. But answer those problems. Do your homework. Oh my God. Homework makes this class so much less stressful, Whatever is the right way to say that. But do your homework. It helps your grade so much. And it makes you better at physics. So it makes the test less stressful. Do I need to say anything else? Oh. I'll be talking to Dr. Marble soon because I'll admit I do not know whenever y'all's first test is. I want to say it's coming up soon, but I do not know. So I might just make y'all stress for nothing. Whenever that is, I'll have my first test prep. I have a session. It's not 12 yet, so not today, but tomorrow. So Monday, I will be having my first Monday session. Please come. I need to make my worksheet for that, but once I get that worked out, I will have it ready for y'all to download from my website. Please come visit my website. A lot of y'all email me whenever y'all could just look at my website and the answer is there. I will be uploading this video. At the same time, I'll be uploading my answer sheet. Maybe not this answer sheet, but an answer sheet that's correct. I probably should have been doing it as I was doing this. Yeah, I'll upload my answer sheet it's going to be right next to the Word document. My answer sheet to the last worksheet is up there. My YouTube link is there, so you can watch this video and my last video. Although if you're watching this video, you probably know that already. And yeah, at this point, I'm just ranting.